How's it going, everybody? I finally got all the parts in for my LEDs, all the resistors and capacitors and everything that I needed for it. So I got it all put together finally, and now it's time to show you guys what I've been trying to talk about, or what I'm thinking about doing for my turn signals. So here's what I finally got going on right here. There's a whole bunch of wires going everywhere, but the gist of it is there's two 4017 decade counters and one 555 timer. So this thing sends out the pulse, a certain pulse, based on what size capacitor you use. There's a capacitor right here. If you change this capacitor, it changes the frequency, and I can do that for you. But it changes the frequency of how each one of these lights up. So each counter has its own set of lights. This rear counter controls these lights, and this front counter controls these lights over here. So doing one decade counter is really simple. You just hook it up based on the pinouts, which the pinouts are right there. There's the 4017. It's got all the pinouts. These are all LED outputs, and then the basic stuff. And here's the 555 timer output stuff. And this is kind of the schematic that I used. Now, I used everything on here except for this capacitor and this capacitor. It wasn't allowing me to get the second one going. So as it goes, this timer sends out a pulse. That pulse gets transferred over to this one, which is right here. I can go like this, I guess. This pulse sends to this one to start blinking, and then once that one gets done, pin 11, which is the very last output, that pin 11 is your last output, that will hold power and then send the pulse back over to this first one, allowing these ones to go. And it sounds really simple, but in practice, it's not that easy. It's really easy to get one going, but two is a different story, or three or four, and you can add to these as much as you can. So I'll show you what I have going. Now these will go in line. I can't fit the LEDs. I only have one breadboard here. That's what this white thing's called, is breadboard. I've only got one breadboard to use, so I had to stack my LEDs up. So, but they'll go start. This will be number 1. It'll go through the 9, and then this will be 10. Go through, will that be 18? 2 sets of 9 on each one. So here we go. I've just got a simple battery charger hooked up to a wall outlet, battery charger, and then some alligator clips hooked on to each outlet. And then those alligator clips go in. That gives me my 12 volt for a battery in through. And once I hook this up, I'll get my lights to start going. So there they are. It will go down this row, and these ones will be at the end of this row going this way. But we've got everything working the way that I want it to. I'm going to turn this off. With these counters going, there has to be what's called an AND gate. So there has to be power coming. Here, the schematic will show it really good. So there has to be power. There's always going to be a pulse coming from number 3. So this gives me my pulse frequency. There's always going to be power going to this AND gate and this AND gate. So an AND gate works by having power on both sides of the diode at once, and it will pull power on this back side and allow the chip to go. And once this very last pin gets high, or becomes high, has a high voltage, or high voltage, it will be high right here and right here, allowing this to pull power from this way, and go back through and allow this chip to start. And I can show you that by putting just a couple LEDs in here. So this is pin 11. Let's see if I can get this in here one-handed. Pin 11. And then this one will be pin 3 for the first one. So what you have to do is you keep this one at pin 11. You have to keep that, like, pause it. You have to completely pause the timer going to this one and send that pulse over to this one. And then once this one hits, it will stop this one, send that pulse over to this one. And you can see it, so this will show you. So this is number 11 output, and that one's number 3 output of the first one. This is 11 of the second one, 3 of the first one. So you essentially have to stop the pulse from each one, depending on where you're at in the cycle. You'll have to stop the pulse and hold it, allow the other one to cycle through, and then send that pulse through again. It's a little bit of cumbersome work, but we got it to work. So this is the main components that I used on getting this to work. I've got my 555 timer, 2 4017 decade counters, assortment of capacitors so I can change the frequency. These are just the wire leads that go between everything that make the connections. Here's a diode. Now this allows current to flow in only one direction. That band right there allows it to flow from, it'd be from the right to the left, and in only that one direction. It won't allow electricity to flow from the left to the right. The same way with an LED. LED works the same way, but that emits light, and this will emit heat as that source. And then the last thing is an assortment of resistors. There's resistors everywhere kind of in here. But I've got assortments, as you can see. I'll bring them over here so you can see. I've got a box full of stuff. There's resistors, all different types of resistors in here. Here's another set of diodes, another different style. A little bit bigger, higher voltage. Yeah, a bunch of wires, leftover stuff. And then I also got an assortment of capacitors. So there's different sizes you can use. So I do believe that this capacitor is a 3.3 farad. So if we go down, or what is this one? Here's a 33, so this is a times 10 capacitor. So putting this capacitor in should allow me to shorten the frequency. There you go. They're going a lot slower because that capacitor has so much more volume that it can accept. So it's taking longer to fill up and then discharge. And every time it discharges, it allows current to flow through. So it's charging up, discharging, charging up, discharging, charging up, discharging. And the higher you go, the slower it'll be. And I can go lower with a smaller resistor. See if we can find a smaller one in here. 3.3. What's this one? They've got the writing on them. Maybe it'll focus. So that's a 33 microfarad. 22. 3.3 is where 0.47. So this one will be a lot smaller. So it doesn't have, it's like filling up a smaller cup with water and then dumping it out. So this one's a much smaller capacitor, which will make it go faster because it will discharge faster. We can take these ones back out because they're not really useful. But there you go. There's a much smaller cup to fill, it goes faster. And we could even change it smaller. I think I've got a 0.1. Now it's a 0.47. I think I've got a 0.1 in here somewhere. Or we can make it super slow with this huge capacitor. What is this one? This one's 100 microfarads. So it'll be really, really slow. I can put it in just because. So it will take a long time to fill that cup up to go to the next one. Now, of course, I don't want that to be my turn signal because that'll be way too slow as it goes across. So the turn signal, or the speed that I've found that I like the most, is this 3.3 right here. That's, yeah. 3.3 microfarads. Get this put in here. Charge it up. And I think that will be a good speed to go across. So it's about 2 seconds worth of lights. And it'll go across, stop, go across, stop, and start again. So now I'll have 3 LEDs at each one. And that will be or actually it will be 6. 3 up top, 3 on the bottom. And that will run each of those. This is the stuff that I really like doing. You kind of get to experiment with some things. Some things, when you experiment, it doesn't go very, very great. But you get a chance to kind of make something work. It kind of took a little bit of finagling to make it work, and a lot of research, that's for sure. But I think I've figured out the best way to go about this. Now I got to figure out how to actually put it into the car. So actually that's not going to be the hard part. The hard part is going to figure out where each wire is going to go behind the taillight. Because doing the LEDs is pretty easy, but putting all the connections to the 400 or 4017, 4017, whatever you want to call it, the decade counter and the timer, the 5x5 timer, those will be a little more difficult than just going to the LEDs, because the middle is on the gate is going to be separate from the outside because the gate lifts up. So I've got to run LEDs then, or wires, up the hatch to the hinge point of the hatch and then back down to the taillight. So it might be, I'm trying to figure out the best way to do it. If I want to run one timer on the inside, run my pulse signal out over to the other timer and have that other timer on the other side, or if I want to have both timers in one place and then run each LED wire around. That'll be a lot more wires, but I think the pulses will, hopefully they'll stay okay. I don't know. I love doing this type of stuff. Electronics are very interesting to me. There's something about sending electricity where you need it to go that is really cool to me. That's pretty tough to do. It took a lot of theory, I guess, to make it work, but it's working great. Using the AND gates, sending power to both of them, and then pulling that power through another source. It's pretty cool. Anyways, I'll stop rambling here. Thank you guys so much for watching. I hope you like this. I can't wait to get it into the car. I think it's gonna be super cool. So, anyways, thank you guys. Enjoy the rest of your day and have a great one. Bye.